Welcome to Spring LIB.
So Timothy, I'm just going to show you an example of solving a logarithmic equation. And so you solve an inequality up to a certain point the same way you do any other equation. We would add 1 to both sides, and adding anything to both sides does not change the sense of the inequality. It doesn't change the sign. So that would not change, and this would end up being 3. Now I would divide both sides by 2. And again, that dividing by a positive number does not change the sense of the sign. That would just become the log of x is greater than 1.5 or 3/2. Now we have to change this so that it is no longer a logarithmic equation. And this is an x log base 10. So this means 10 to the power of 3/2. And now the question is, do we want 10 to the power of 3/2 to be greater than x, or do we want x to be greater than 10 to the 3/2? So that's what we have to decide. Well, let's look at an inequality and see which way we're going to go. Let's say we take something like this. We know that log of 10 to the log base 10, or let's go 100, is bigger than 1. So if we rewrote this as an exponential, because this means 10 to what power? This is really 2. So 10 to some power, which happens to be to the first power, 10 to the first power needs to be greater than 100. Well, that doesn't work. And if I rewrite this and go this way, that 100 is greater than 10 to the first power. That's the way we want to go. We want to put the argument here, and we want to put the 10 to the power up here. So this is the value that we want, not this one. So when we get out of this logarithmic equation and rewrite it as an exponential, we want to leave this argument right here, that x, and then rewrite 10 to this power and put it over on the other side. So we know that means x has to be bigger than 10 to the 3/2. Hopefully that's helpful.